Hello, everyone. We would like first to thank the colleagues from the CHERISH project for having invited us to do this presentation. So we will make a very quick overview of our projects on coastal archaeology and climate change in Brittany and Northwestern Iberia. So just this first slide, where I will introduce to you the contents of this presentation. So first of all, we will see a little bit the history of our perspective on coastal cultural heritage and climate change. Secondly, the way we record and prioritize action on archaeological sites at risk. Some recent developments, new projects that we began outside Europe, and finally some conclusions. So our research on these topics began with, the origin of this research was the long tradition of coastal archaeology in Brittany since the 19th century. And of course, acknowledging the problem of erosion on these coastal sites, that led to the conformation of a dedicated team in France, Western France, since 2006. So the objectives of this working group were to develop tools and try to provide solutions to the problem of erosion. And the result was the ALERT project that has been running since 2006 until the present day. What is interesting of this history is that at a point in 2010, we decided to extend the tools to other European Atlantic regions. So we thought that there were similar problems elsewhere than in Brittany. And then we wanted to test the suitability of the tools and the solutions we had initially implemented in Brittany. So this led to a transnational team, a transnational collaboration in some of the areas that you see there on the right side of the map. So, as I said, the starting point in Brittany, this problem of erosion and destruction of archaeological sites was the same in other areas, namely in Galicia, Northwest Iberia. So, as many of you know from your own research and activities in other parts of Europe, is that we have this problem that a single event or a few years can completely destroy an archaeological site in our coasts. So what we did was to implement kind of chain operatoire, if you like, a series of methods to provide this solution and to try to improve the research and management of this coastal cultural heritage at risk. So the first of these methods is the dedicated archaeological survey of coastal intertidal areas. So we are specifically surveying dune horizons, cliffs, intertidal zone. And this seems quite straightforward, but in some areas like I said, Galicia, in the north of Iberia, it wasn't really implemented before. So as many of you know as well, this needs for regular visits because of the erosion of the archaeological record, the rate of erosion, the visibility. And what we realized is that the best group size, if you like, are small teams of 5-6 people. In our experience, that was very, very effective. Also, we have to deal with problems of accessibility sometimes. We're going to visit small islands, small islets, and also seasonal problems related to some coastal areas, very attractive to tourism, for example. So a second and complementary method is geophysics. So we've been using this in order to anticipate potential hidden sites at risk. They also allow us, these techniques also allow us to delimit the extension of already known sites and contribute in this way to, for example, the excavation of the sites in later phase. Of course, it is complementary to pedestrian survey, but we have identified as well certain issues with this implementation of these techniques, like the sensitivity of water content or salinity with some of the techniques. Equally, and this is a problem again general to other areas of Atlantic Europe. We had issues with seasonal sediment deposition and biological deposition such as algae. And you see on the upper right image of this slide one geophysical survey with this layer of algae that was, of course, posing problems for the results. A third and most important for us method is the development of vulnerability analysis and the integration of a public science perspective. So what we developed in Brittany initially and then applied, as I said, to other areas was a vulnerability evaluation form available in printed and digital versions, if you like. And this form allows us to rate the risks and resilience of archaeological sites and archaeological remains. So what we have is a centralized database and cartographic interface from which we can then give a multi-scale, provide a multi-scale analysis of this data. The result is a site ranking, so through a vulnerability score. And these are tools that are open to managers and, as I said, the public that participate in the collection of the data. So this whole vulnerability analysis is really key for the decision-making process. Along with this vulnerability form or analysis, we have developed other public science initiatives like the one we are presenting you here. So this is a crowdsourcing initiative we made a few years ago in one of the small islands of Northwestern Iberia. What we did was to ask the public to contribute with us in the research process, sending us photographs and videos of the archaeological sites of this small island, and because it's a very touristic location during the summer season. So this was really, really interesting. We did this through the internet, Facebook, Twitter, etc. We received a lot of images, a lot of videos that were really, really interesting to complete our research. And the public really, the society, local society, really liked this initiative and contributed a lot to it. So what we have here is just some examples of the images that we received, a total of 677, the earliest of which dated from the 1990s. So, resulting from the previous methods, survey, vulnerability analysis, and crowdsourcing, and other public science initiatives, we can select then the most vulnerable sites and monitor them. So we are using terrestrial laser scanning and digital photogrammetry to monitor the changes on these sites. What this allows us to do is to obtain digital elevation models, point clouds, and to provide a state of the changes that every site suffers from season to season or from different visits that we can make. What this leads to is to obtain temporal series and site evolution. So what you have here in the image, so upper left is a classic example of digital photogrammetry. On the right, the terrestrial laser scanning, and here below, what we have is the evolution of one of these sites with photographs taken with this crowdsourcing initiative I mentioned before. In 2011, photographs taken by our team of experts in 2014, and then the comparison of the evolution of the sites through digital data. So all this process can lead to specific actions, and one of these actions, as you also know, is, for example, the excavation of most vulnerable sites. So we try to analyze all the information that we have obtained with the previous phases and excavate only those sites that are really the most vulnerable and those with the highest scientific potential. So what is interesting here again is that we excavate these sites with professionals, but also with volunteers. There is a question that many of you also face in your research, of course, is that of the natural protected areas. So this is something that we have to take into account, because sometimes we have strong limitations due to natural protected areas, natural species, seasonal nesting periods of some birds. So this has to be taken into account, especially when we are dealing with archaeological sites at risk. So these natural areas may need specific planning before the excavation. Of course, we need an administrative rapid response for trying to shorten all these delays, if you like. So, as I said, this is globally our series of methods, our phases of working in these Atlantic areas. Mostly we've been doing this in Europe, as I said, but since 2019 we are expanding this perspective to other Atlantic areas, and namely we are working in the French West Indies, in the islands of Guadeloupe and San Martin. So what we are doing now is to adapt this methodology to a new context, really, because again we realize that the problems are similar, the tools will be suitable for this, but we have some additional hazards. For example, hurricanes, earthquakes that can also trigger the archaeology of these coastal areas. And again, we will look at the vulnerability of coastal sites of risk. We will prioritize action. We will include, of course, citizen science, and all our work, as we've been doing in Europe, is based on a collaborative network with local authorities, museums, local associations, and so on. So we hope we will can provide you with fresh information on this new project in the next few years. So just some conclusions to finish this very, of course, quick overview of what's been our research since 2006. What we'd like to highlight mainly is the relevance of this transregional and transnational perspective of the ALER project that was initially begun in Brittany. Because we know most of the initiatives on coastal, cultural heritage and climate change are usually centered on local and regional, at most national perspectives. So this is interesting because we could validate and extend the tools we have developed in Brittany to different regions, and so providing this kind of chain operatoire from desk-based planning, to integration at different levels. As I said, the public science engagement is key for us, as for many other coastal cultural heritage projects, and it's at the core of all our actions. So just to finish with one particular milestone, of course, added to the fact of monitoring and rescuing, if you like, the archaeological sites. But one very interesting milestone has been the sensibilization of the public, the decision makers, and the stakeholders. So, of course, we cannot be everywhere, we cannot monitor everything, we cannot know when an archaeological site appears or disappears. So if we have this wider support, this wider network, and if we gain the public sensibility, if you like, I think there's a lot of, it's something that we should aim for, and is probably the best result of our actions. So that's all. Thank you very much for your attention.